the answer key and talk to Mr. Scharnhorst about things that you don't understand. But if you guys are needing some help, let me go over a couple of the problems. All right. Now, in this first one, it should be pretty straightforward how we got that the weight of the object is 98 newtons. Okay, 10 times 9.8. It should be obvious how we get the amount of force acting in the x direction, 60 times cosine 30, and how we got force acting in the y direction, that is 60 times sine of 30. And then remember that this force, the 30 newtons here, that's taking the load off of my normal force. So this is helping out my normal force. That's why my normal force is actually only 68 newtons. That comes from 98 being the full weight minus 30. So this force and my normal force together are balancing my weight. Okay, now in your homework, I'm actually going to give you a problem where there's a force pushing down on the box instead of lifting up on the box. So you'll have to think about what you need to do instead of subtracting the 30 if that's the case, okay? All right, so from there we had our normal force. We were able to figure out our force of friction acting on the box because that's just mu, which we said was 0.3, times normal force, which is going to give us negative 20.4 newtons. It's negative because it's acting in the opposite direction that we're pulling, so it's resisting our motion. Okay. We already said that we have balanced forces vertically, and then we're saying, okay, we want to know our net force in the x direction, how much force is actually pulling it in the x direction overall. So that's just going to be our force from our pull in the x direction minus the force of friction, gives us 31.56 newtons, or about, technically I gave you a 60 here, so we would have to round that off to 30 newtons if we were being careful with our sig figs, which is about 3 meters per second squared. Okay, sorry. Did not intend to do that. Maybe you guys didn't notice, never mind. I'm not even there and I'm still making you laugh, right? Okay. So then the next question was the work is equal to force times the distance parallel. So if we're talking about force times distance parallel, then we need to just focus on the force that is actually parallel to the direction we're pulling, and that's the 51.96, okay? Now the overall work is actually just going to be our net force in the x direction, 31.56 newtons, times our distance, which was 5 meters. You might be wondering, wait a minute, didn't you just say 51.96? Well, that's the amount of work that you are going to do on the box, and so that's going to be 51.96 times 5. Friction is also going to do work on the box, which would be the negative 20.4 newtons times 5 meters. And what my question is actually asking is how much work is done on the box. And so that is talking about the total amount of force acting on the box times the distance. So I'll do this much work. The friction will do this much work, which is actually negative, slowing it down, taking energy away from the box. So our total work is going to be those two combined, which will be this much. Okay. Then from there, you're doing these problems with the, this one's a little bit easier, force at an angle, also 45 degrees, which was a little bit easier. And essentially, we're taking power is equal to work over time. Work is equal to force times cosine theta times distance. And so there you go, 26.52 watts. And that should be all of the ones that are on a flat surface.